We are a company called Iterative, although most people actually know us as DVC. That's our main product. We have an upcoming product that I'll mention very briefly called DVCX. If you are working with, this conference is a lot about large language models, Gen AI, stuff like that, which is currently in the vogue. This is our answer to that. Working with very large data sets of unstructured data at scale, doing complex operations. There will be a talk at the conference, not from me though. I will highlight that a little bit later in the talk. Because what I'll be mostly talking about are these other two things, essentially. So the one sort of represented by DVC as the main tool, which helps you apply GitOps principles to machine learning. And then also this collaborative and sharing aspect of it, which is our Studio platform. DVC is free open source software, and all the libraries around it are free open source. Studio is a paid product, although it is available for on an individual limited basis also for free. It is not necessary if you have a small project, maybe a team of 1 or 2 people, or just 1 or 2 models. You're probably okay with the free open source stuff. If you're doing anything larger in an organization, or if you want to share things with other colleagues who are maybe not as technical, who don't want to work with the command line interface and stuff like that, then this is a great tool to include as well. Don't worry, I'll talk about all of this stuff in detail. Let me just mention that all of this is going to be compatible with any cloud, also on premises. You can use any GitForge like GitHub, GitLab, Bitbucket. So all of that should be compatible, but today we will focus on an example that's on GitHub as the code, and that will use AWS for versioning, as a storage for versioning data, and also a place where we'll deploy our model. I should also say maybe something about myself. I'm Tibor. I'm an MLOps solutions engineer at Iterative. I have quite a bit of experience in consulting. Before that, I was in the academia doing pure mathematics, more probability theory related. So that's maybe tangentially related to machine learning. So that's how I ended up where I am today. All right. So let me actually, before we start with the motivation and with explanation of all the individual tools, let me go back to the repository itself. And let me make this bigger. Let me go to the repository itself, because as I mentioned, this is supposed to be interactive, and ideally we'll get everybody up to speed. So I copied the link to the repository, so you can go here and fork it, or you can clone it if you are and use it directly if you're invited to the repo. And then we will also need to set up a Python virtual environment. So I would rather do this now because it can take some time to download and install the libraries. So let's first install everything, then I'll be talking for a bit, and then we'll go into the more interactive part. So I'll be actually following along with you. I already have the repository cloned, so that I will not do again. Okay, so let's update. But I will be installing everything together with you. This is just an installation of an ordinary Python environment, but I wrote this makefile to make it all just a little bit snappier. So there's a make venv command. If you run that, it's just going to create a Python virtual environment in this .venv folder and install the libraries that we'll need, including DVC. So let me just call that here, make venv, and you can do the same. If somehow, for some reason, you can't use make, you can just copy this from the repository. You can copy these commands and just run them manually. So as this is being installed, and I think it's going to be a bit faster here because I have already everything cached, but you might not. So let's fill the time with our with the overview of what we're going to be doing today. So first of all, okay, GitOps, why GitOps in the first place? Why would you want to use GitOps in your machine learning? So, GitOps in general, I would say this sentence kind of summarizes why GitOps is useful as best as one sentence can. So you use the Git repository as the single source of truth for everything that you do, ideally, right? So obviously you have your code there, but you want to you want to concentrate as much information as you can in the Git repo, because it will help you make things, for example, a lot more reproducible, because everything is right there. If I go to a specific commit, I can reproduce everything that I've done, whatever it was that I was doing, because all the information is right there. And if you're using a Git forge like GitHub, GitLab, Bitbucket, you usually have some CI/CD tools already there, and it's very easy to then connect whatever you're doing to those CI/CD pipelines and automate things as much as possible. And that again facilitates reproducibility, because again, you can run everything right there exactly in the same way, not relying on local machines, and it's also more secure. So, all right. So let's say that we agree that GitOps is a good idea for machine learning. So how do we go about that? So if we just have code, that's easy. We have Git, that's solved. You can use GitOps. If you have infrastructure, and that's kind of maybe going to the evolution of GitOps, then you use infrastructure as code tools like Terraform, right? So they kind of contain a prescription of your infrastructure, then you then set up maybe in your cloud environment. And but okay, so what happens if you have data, or what happens if you want to use a GitOps approach to models and their lifecycle? So this is exactly what we're going to look at today. And we're going to use the DBC ecosystem. So it's DBC and related libraries and tools, which you can sort of imagine as a mix of Terraform and Git for data and models. So it is like Git in the sense that a lot of the logic behind DBC is very similar to how Git operates. It does not replace Git, it rather interacts with it, as we'll see. And it is like Terraform in that it allows you to take something that is not code and sort of turn it into code, or at least tightly couple it to code, so that you can use a GitOps approach. All right, so that's that. Let me just outline the plan for the workshop, what we'll do. So first, we will use DBC in our repository and to get some data to train our model, and we will use DBC to also connect it to our Git repo to be bound to code. How that happens, I will explain in a moment. Then once we have the raw data, we want to create a training pipeline for our model. We want it to be reproducible, which also will mean versioning each of the runs. And once again, this way, connecting it tightly to our Git repository. We'll use that pipeline to run some experiments, training our model, and we will compare them. We will use our Studio platform for that. You couldn't do that locally without it, but if you want to cooperate with many people, Studio is the best thing to do that. And we will compare them live. So we will have live experiments, and this is also the reason why I wanted to invite people to try things together in the same repository, in the same project, because we will see all of these experiments run by all of us together live as they're being trained. And I will also explain how this is all connected to Git and how it all works, at least on a high level. Then, okay, so we'll run all these experiments, but then we want to take at least some of them. Hopefully, some of them were useful enough to consider registering as models that we maybe will later put to production. So we will create a model registry, which is separate from our experiment tracker, and add versions to those models, and maybe track some stages of their life cycle, a development version, a production version. You could, of course, come up with many other stages as well. And we will see how that's, again, done with GitOps. So there's a bit of a spoiler. it involves Git tags. I will get into how that's done later on. Now, if we have that, and if there is that connection to the Git repo, we will also see how we can use it to connect the actions in the model registry to a continuous deployment pipeline. And finally, we'll actually deploy the model, and so that you believe me that it's deployed, we will run some inference on that. The last two steps will depend on using our AWS account, which means setting up credentials and things like that. So those will not be interactive, unfortunately, anymore. But everything up to that will be something that you can do together with me. You will still be able to do this, of course, but you will have to use your own account, your own AWS services. So there's other things that we could mention that I at least want to mention, but we won't have time to do. One is that you can actually experiment and use DBC inside Jupyter notebooks. It's not all that more difficult. It's actually not, it's easier actually. But since this is an MLOps conference, I feel like everybody hates Jupyter as long as you're talking to MLOps people. So we're not going to go that route. It's good for data scientists. It's great for prototyping, but it won't be something that we'll look at today in detail. We also have a VS Code extension. I'll maybe show it quickly, but we will be focusing mostly on Studio, which has the same functionality and more actually. But it contains all the functionality in the VS Code extension. Only it will also allow us to share it, not just have it locally, but share with colleagues. You are my colleagues in our data science team today, at least those that I invited to our repository. Then we could also just move everything to cloud, even run experiments there, do everything via CI. We have also tools for that. I won't get into that because we don't have time for it, but that could even step up the GitOps approach even further. We could create a feature store, dataset registry. There was just a talk about a feature store, I think, or maybe it's still ongoing. So you can do that with DBC. We won't get into that. And there's this one last thing that I want to mention, and I mentioned already a little bit, this DBCX product for managing large unstructured data. When I say large, I mean like millions, billions of images. And there's going to be a talk from Dmitry, our CEO, 2 days from now at 11:30 local time of the conference. So go there if you're at the conference, or join it remotely if you're interested. One last thing that we actually need to set up before we start, and we only need to do that with the people who are going to be collaborating directly with us, is to set up the Studio platform. So actually, let me just introduce it a little bit, because I haven't said much about it except that we have that. So Studio is a platform where you can use all of our free open source software, basically, but collaborate on it with others. You can also run things directly from Studio if you're not familiar, or if you're not interested in using CLI tools. And it also has a model registry for all your projects, which we will make use of. And it also allows you to share live experiments. That is to say, as they're being trained, you can see the results. So we already have, well, if I go to my Studio, if I go to my Studio account here, you can see that I have two projects in this MLOps World team. So this is a team that Jervis, I think, invited people who are invited to the GitHub repo to collaborate in. So everyone who's in will be able to participate. For the rest, you can, first of all, there's going to be, this project is going to be public. So you should be able to also access this. Maybe Jervis can copy a link to this to the chat. Or you can set up your own projects. You can create an account. Actually, let me log out for a second. And you can just sign in. If you use GitHub, and you can just use that, that's the easiest way. Or you can just sign up directly, using your email. I'll just do it now. Or you can just decide not to use Studio if you're doing things individually. That's also possible, but some of the functionality will be it will be available using the CLI, but I will not be showing that at the during the workshop today. So let me just jump here into the MLOps work team. By the way, everybody who's invited, please also do that. But you don't actually need it right that way, but you will need that. And let us do one more thing here. We'll go to the profile. And here, if we scroll down to the Studio Access token, let me actually delete this because you won't have it yet. And click on Generate New Token. This will generate it, and then you just copy it here. And if you have all that, by the way, this entire, these steps are also covered in the README in the repository. So if I go too fast, you can always have a look at this README markdown file in the repo that you hopefully, at least some people just cloned. And then you can copy the Studio Access token and then configure DVC to use it. Now, the reason we're doing this is to allow DVC to share metrics from experiments as they are being trained. So this is the collaborative aspect, and we will just set it up. So let me just rewrite this instead of copying it. DVC, actually, one more thing, sorry. We need to activate our virtual environment. So about the credentials, S3 credentials, those you will not actually be needing in the end. I left there the makefile for myself because I will need that to push things to a remote, DVC remote, basically to S3. I will explain that in a moment, so that we can then deploy the model. But for the collaborative stuff that we'll do together, you don't actually need them. So you can ignore that S3 credential stuff for the moment. I'll just go through it quickly when I set it up, but you don't have to do it. And you don't actually have the environmental file with the credentials, so you won't be able to. Okay, so let me just activate my virtual environment. Just source venv bin activate. And now that I have DVC up and running, I will configure it to connect to our studio project. I will then go through the project a bit later, how it works. So for now, don't worry about not understanding everything. Just please follow me with the configuration. And this is the last step in the configuration, so you don't have to worry about doing nothing but this throughout the workshop. So DVC config, global, and then studio.token, and then I'll just paste the token that was just generated, and it should connect my account to Studio. I can actually check it because I use the DVC extension here, so I can actually check if it all run. Yeah, it seems to be working fine. Like I said, I won't go too much into the DVC VS Code extension because that would be, again, me talking even more than I will already do. But by this command, you should set up DVC so that it will communicate with Studio whenever we're training something. Okay, so let me just pause here because this is the entirety of the setup. Okay, zoom a little. I can zoom. Yeah, Conda. I think the only step needed based on the README is pip install. Let me know if I missed that step. No, yeah, that's correct. Yeah, if you use Conda, you really just need to install the requirements, and if you then jump into your Conda environment, it's going to work fine. So hopefully things are a bit easier to read now. So as I mentioned, if there are any steps that were too quick, you can have a look at the README here, or you can ask in the chat, and I think that Jervis can help with that. So now we're at a point where we can actually start working on the project. And the first thing that we'll need to do is to get some data. So let's maybe just run a command first, and then I'll explain what's going on, what just happened. So we have in our README file, we have this command dvc import, and then there's a URL, some path, and another path. So for now, let's just all copy this. And as we run it, I will explain what it just did. Copy this and run this command. I'm not sure if you see this. I'll move it away. Okay. And so now something's happening. Something's being downloaded. And we'll actually see some new data coming in. So what's just happened is that we use DVC to import data from our remote dataset registry. I won't go into detail about how you set up the registry. It's actually not that difficult, but it contains the data that we'll be using as raw data for our datasets. Raw data for our work. And if I go into it, you see that there are a bunch of things here. So there are the pool data here. We have images. If I look at some of them, these are just images, satellite images of swimming pools in a city. You know, it's from Brazil, I think, all of these. We have masks, which will tell us where the swimming pools are for training. You won't see much here because it's zeros and ones. So you'd have to have a very good eyesight to differentiate the shade. And we have more importantly, or most importantly, perhaps, we have this pool data.dvc file. Now, this may sound or look like gibberish, but the important thing here is to notice that there's this hash at the top of the file. And what this hash does is it uniquely identifies the data set for DVC. So this works exactly the same way that if you have Git, you version your code, and you have hashes of a specific commit. So here you have also, or any file really, and here you have hashes for the pool data set that we'll be using. Let me jump one more time and one last time into the slides so I can explain how DVC actually does this and what it does with this. So normally you would have something like, you have code, you version it with Git, you have some Git cache, and then you push it to, let's say, GitHub in our case. And if you want to retrieve it from there, you use Git pull. But what happens if you have a larger data set like this one? You have a 10 gigabyte data set. You can't really push it to GitHub. You could theoretically use Git large file storage, but it has its limitations. So you really don't want to do that on a regular basis. So what you would do normally is maybe you would just upload it to S3 and then try to create a link to that file somehow. But DVC actually already does all of that for you, and using those hashes, it can retrieve all of that securely and connect it directly to a specific commit when you need it. So the way it does this is this. So and that's the .dvc file that I just showed. So instead of that data set that you will be using when you train the model, you don't actually version that with Git. Instead, you use DVC to create this .dvc file. We just created that with the DVC import command, but there are other ways of adding data, even when you have them locally. You can also parameterize it as well. It uses those hashes to keep track of this. So there was a question, is it at the directory level? It can be both. It depends what you specify when you import things. So here we actually used the entire directory. So the entire directory uses that hash. And but if you just specified a single file that you want to add and version with DVC, then it will be related to that. So yeah, and yes, it does use MD5 hashes by default. So I'm not sure. I don't think you can change that, to be honest. But yeah, this is how it works normally. And so what happens is that DVC kind of replaces that 10 gigabyte file with this 10 kilobyte file. This is obviously an example. It's even smaller, really. but which works as a sort of a pointer to that file that you upload to S3. In fact, you don't upload it there yourself. You use DVC to do that using a very similar command to Git. So you use DVC push to push your data set from a local environment to your remote environment, to your remote storage, like S3. It can also be an NAS drive, for example, if you're on premise. And you use DVC pull to retrieve it back again to your local environment. And this dataset.dvc file is the glue that kind of ties all of this together. So that's the thing that makes it possible to really version your data together with your code and operate with it much like you would with Git. All right, so that's what we did right now. We created this metadata.dvc file for our data. So if we now push, if you look at my Git status, we have the pull_data.dvc file, and then we have this git ignore, which is saying to Git, do not bother with the pull data because that's versioned by DVC. And you replace all of that from the perspective of Git by the data.dvc. In fact, I think you can actually replace the MD5. So let me check that, maybe, but this is definitely what's happening by default. Okay, so we have our data set, we have our raw data, we have it versioned by DVC. If we now push things to Git, it will know where to look for the exact data set that we need. And since we have that hash, which uniquely identifies the data, it will allow us to reproduce it reliably and always get the same data set for this commit. We would then use DVC push to push the data to the DVC remote. And whenever we want to retrieve it, we would use DVC pull. But right now we already have that. We already imported the data and we have them locally, so we can continue as we are. Okay, so then the next thing is we want to train our model, right? We have our raw data, but now we want to have a model. So the next step normally would be, to explore the data, do some analysis, maybe prototype things in notebooks. They are here, by the way. You can actually have a look at a training notebook in Jupyter, but maybe later. But we're going to skip that a little bit and assume that we already have a good idea how to train our model. We understand our data. Now we just need to create a training pipeline which does all of that. So let me just go very briefly through these three scripts that we already have, which are going to together consist, our training pipeline is going to consist of all of those. So that's not going to surprise you much. There's a data splitting script, which does just what it says. It splits data to a training data set and a test data set. We have a training script, which then takes those training data and it actually uses fast AI, just so that the script is there. And trains our model. And then we have an evaluate script, which calculates a bunch of metrics so that we evaluates them on a test set so that we know whether the model was any good or not. Okay, but now we want to run them, and we want to run them ideally in a reproducible way. So the simplest thing maybe you could do is to create a makefile like this one and just say, okay, run these three things in order in which you want to run them. Then you could be a bit more ambitious and instead of that use maybe Airflow, which is going to be a lot more work. But instead, what we're going to do here is we're going to use these GDC pipelines. So this is something that you define in a file like this. It's a YAML file called dvc.yaml. And as you can see, we define some stages. For every stage, there's a command, what should even run in that stage. There are some dependencies, outputs, and you can parameterize the stage. So it looks quite lightweight, especially compared to something like Airflow. It is lightweight, and it has some advantages also in that it is, again, it has GitOps in mind when it was developed. It had GitOps in mind when it was developed. And so all of the stages, all that's going to happen here is going to be versioned once again. In a moment, I'll explain how. Let me just go through. Let me just go through the stages a little bit more. So there's the parameters. They are defined here in the params.yaml file, where for every stage, you can just define what the parameters are, and then you can use those parameters in your scripts. So here, for example, we have a base learning rate, number of epochs for our training, size of the image to be used, or the architecture of the neural network that we'll use to train it on. But those can be in anything really. And those parameters are listed here for each stage as a type of dependency. Now, the difference here between maybe a pipeline where you have dependencies based on stages, so that, for example, the train stage depends on the data split stage. Here we define our dependencies by the outputs, or just in general files that serve as dependencies of a stage. So, for example, here we can see that in the data split stage, we have these two outputs, the train data and the test data. And we use the train data as the dependency of the training stage. And what this does is, first of all, DVC, whenever we run a stage, it will automatically version, just as we did with the data sets, it will version the outputs of this stage. So it will version all the test data and the train data that were produced by this run of the pipeline. And it also looks at the dependencies of each stage and checks whether they changed or not. If they didn't change from the last run, maybe we rerun it a couple of times, then it doesn't even bother redoing that stage at all, because it knows that it will be exactly the same. Since the pipeline is fully reproducible, all of these data are versioned, they're uniquely identified by their hash, whether it's a script that's versioned by Git, or whether it's a data set that's versioned by DVC. DVC keeps track of all of that and can skip a stage if there's no reason to rerun it. I will show that in a moment. But now I think it's actually a good time to start experimenting. And after we're done with that, I'll go through the outputs of that experimentation, which is actually outputs of all of these pipelines that we're going to run, and explain how all of that works. So for now, you can just think of this as a lightweight pipelining tool, which specifies dependencies of stages not on previous stages, but on their outputs or just any data. So what we're going to do is actually also described here in the README file. It's quite simple. We're actually going to run the DVC run. Let me actually do the run first myself, because I want to show you something, and then we can actually let everybody do that. And I would actually encourage you to do it, because we will be able to observe it all of us live as it's being trained. So let me just jump into our MLOps work team and to our project. And it looks like someone's already been playing with this. These are actually previous experiments. Okay, so that's fine, but we're going to create new ones. So let me run an experiment by this command, dvc-run. What this command does, it actually runs what is described in this pipeline. So basically, it will run all of these scripts using the parameters mentioned here, and it will create a DVC experiment. I will then talk a little bit about what the DVC experiment is and how it works, but let me just run it now. So now it's reproducing everything, and it's running the stages. It's running the data split stage. Now the stage is done. It's running the training stage, and it's going to go through all of the epochs. I think we have, let me see, we have 8 epochs. So it's going to do the 8 epochs. Now, since we connected our model we connected our local environment to the studio, you can see that the experiments are being tracked live. And now it looks that actually people are participating, which is great. You can try to change the params.yaml file also if you want to, so that we don't all have exactly the same experiments. And if I actually look at this in Studio in the project, first of all, we can see that it's being updated. So somebody's much faster than me here. I'm at the second step, and I'm now at the third one. I can actually see the training live. So for example, we have the evaluation loss here. We're at the third step, and now we're at the fourth one, and we can see how it's being updated. And the same goes for all the other experiments from all the other people who joined. Among the, I think, about 20 people who started the project. Who were invited to the project. So we have experiments from everyone here. So, for example, here we got Andrzej, Zera. Sorry if I mispronounced the name. We got Michael here, and we get all of the other things as well. Yeah. So it looks like these were actually some people who tried things out even before I got to it, which is great. So we have a lot of experiments. Maybe some more will come up, and we can actually take those and look at those together. So compare the experiments here in Studio. Actually, let me just take some that are already finished. Here I can actually click to compare these. So I can see how the metrics differ between the two experiments. And, I can also, I won't go into too much detail, but we can also look at trends, how things evolve over time with different experiments. We can compare the graphs, like an overlay, how things are being trained. And in fact, so this experiment was stopped for some reason, or maybe it just had one epoch, I'm not sure. So we can do all of that in Studio. And you can do that locally, by the way. You can do all this locally, but you won't be able to collaborate. You will only see your experiments on your machine. You can use the VS Code extension to have very similar visualization, but you won't be able to collaborate with others. Now, there are some questions. So I had a talk with the CTO last week, and he said DVC probably uses the Merkle tree for versioning. Is that right? Well, it works pretty much the same way that Git operates. I'm actually not going to be able to answer this in too much detail, but I can at least say that if you version something with DVC, it not only it stores that hash, as I mentioned, and it stores that here in the cache first. So here you can actually see the files, and you can see that this structure is exactly the same. If you ever look at your .git file in your repository and you see the cache, you will see very similar structure as this one here. And here you have the versioned stuff, which corresponds to the hashes that we have, and it will be versioned exactly the same way. So actually, I think the first two letters correspond to the beginning of the hash, and then the rest to the rest of the file. And this, like I said, it works exactly like Git. And the advantage of that is that if you use the same file in multiple commits, for example, you push it to your remote, then if you use it in a different commit again, and it's exactly the same file, then there are no redundant copies. So on your remote, much like with Git, DVC is smart enough to just locate the file that's already there because it has the hashes for that. And it realizes, okay, well, this that you just created is already there. So I'm not going to push it to remote again. I'm just going to refer to it. And therefore, you can always fetch it again. Which also means that if you have a lot of stuff that you version, but you don't change it too much, you still need to upload it for the first time. But then, as you work with the same data more and more, all of this stuff becomes a lot faster because you don't need to keep pushing the stuff that's already there. I don't know if that answers the question enough, but maybe we can talk about it later. There's another question. Any lessons learned trying to combine DBC with Spark processing and or Databricks and data lakes in general? Yeah, so this is actually something we're currently working on actively together with Databricks as it happens. If you go to our documentation, you can actually use you can actually look at some integrations with Databricks, and there's a little bit about this in the docs. There are some limitations, chiefly because of how Databricks works, and it doesn't really allow you to access, unfortunately, doesn't allow you to access the Git repository directly. I'm not sure why it works like that, but that's just how it is. And this is also something that we want to kind of improve in our cooperation with them. But right now, there are some ways that you can make it work together. There are some workarounds. So, if you're interested in that, please have a look at the docs of Databricks integration. We will be updating them as that collaboration continues. Okay, so we go. So we're getting more and more experiments here. That's great. And I'm going to cheat here a little bit because it's possible that some of you created experiments with better metrics than mine. But unfortunately, I'm the only person with credentials to AWS. So if we want to deploy something to a SageMaker endpoint, it will have to be my contribution. So now that but before we actually do that, I don't want to jump too far ahead because I want to explain how these experiments all work, what we just did even when we ran DVC Exprun, and how that manifests not just in Studio as those metrics are being fetched from our local environments, but also in our Git repository, because again, we want to keep everything GitOps. So how does that work? Okay, so first of all, let's see this dvc.log file here. So this was created as we ran the experiment, and it's something similar to the .dvc file, except that it versions the entire pipeline rather than just a data set here. But it has a very similar structure if you look at it, except that it kind of keeps tracks of the stages as well, and all of the inputs and all of the outputs of those stages and their exact hashes once again. And this is the ingredient that DVC uses to decide whether to rerun a stage or not. Because if I have a stage whose dependencies haven't changed at all, then there's no reason to rerun it because the output will be exactly the same, unless I have some stuff that's random in the pipeline or something like that, which I shouldn't really. Or I should fix the random seeds like we do here. And so this is capturing the state of the pipeline as it was run now. And if I wanted to make this persistent, again, in our repository, I would just commit this. I would just add this and create a commit and push it to our Git repository. And we will have this log file, which we can then again use using DVC pool to get all of the data that were created running this pipeline. So to reproduce it 100%. Or, version and reproduce it. That's what this log file is for. So actually, let me just demonstrate this. If I run this again, I'll run the DVC Exprun again. I could also run a slightly different command, which doesn't create an experiment, but just for the sake of argument or sake of simplicity, actually, let me do this. And you can see that it's going to create a new experiment called Rummy Hard, or what was the name? Rummy Hard. But actually, it didn't run any stages. Now it's really fast because nothing's changed. So it can just skip everything because the outcome of that experiment is exactly the same. And as you can see, the log file hasn't changed either. So that's this file. And this is what creates the versioning aspect of DVC pipelines. and the reproducibility of them. And through this dvc.log file, we have it again all connected to Git. Now, there's a few more things that happened, and there's this dvc.yaml file here that we had our stages in, but now it creates something, and now it contains something else, and we didn't actually create this. There's this, there's more information about the plots, metrics, parameters, and where they are stored, and also an artifact. This will be our model artifact. So where did this all come from? And the answer to that is, I also realized there are some questions, but I'll get to them in a second. So the answer to this is, if we actually go to our scripts, and let me just go to the train script, because with the evaluate script, it's going to be almost the same. At the beginning here, we import this dvc live library, and specifically this live object. We also import this callback, which I'll mention also. And this is a library that kind of serves two purposes. First of all, it's a Python library that allows you to basically edit this file and thus version the products of those pipelines as, for example, metrics, plots, or artifacts that you want to keep track of in your pipeline. And the dvc live library allows you to do this in your Python code. But why is it called live? And the reason for that is actually maybe now here best hidden in the way we call the callback, but you could also run it differently. It allows us to create live updates of metrics. And this is exactly what is the magic behind the live updating experiments in Studio that we had. Now, this works without Studio, but you will only have the live updating locally. If you have Studio, then, and with that token that we put in at the beginning, we also managed to share this with our colleagues, with the rest of the people at the workshop, basically. I won't get into too much detail of the syntax of the dvc live. Let me just say that it's, if you're used to something like SageMaker experiments or MLflow, it works very similarly. So you have this live context here, and inside of it, we call methods like log artifact, log image, log param, log metrics, etc. We fill in the content of those. And what live does, it actually edits this .yaml file. And then, since dvc is connected to Studio, it passes all of that information to Studio as well. And all of this is happening as the scripts are running. So that's why we get these constant updates. Here we're using the dvc live callback. It's a callback specifically for FastAI, but we have them for many frameworks. And it's just a convenience where you just plug that into the fine-tuning method in FastAI, and all the metrics that come out of that are going to be parsed, and they're going to be returned by the callback. So again, as we train those epochs, we retrieve all of these metrics as things are being trained. Okay, so let me maybe now pause and go to the questions. So, can I use Artifactory as my artifact store with DVC pointing to Artifactory? I think it might be possible, but essentially DVC just needs a storage, and there are many ways that you can connect to it. There are actually guides we have. I think it's in the Get Started. I think it's going to be in the user guide. So you can use any of the major clouds. You can use a NAS drive. You can use anything that you can connect with SSH to. You can use something like Minio. I haven't tried it with Artifactory, to be honest, but the Artifactory is going to use some storage itself. So you can just use the same storage if you want to, and it's going to communicate with that. So I think it should be, in principle, possible. Let me just see where it is here. Okay, SSH maybe. Yeah, so for example, here's remote storage. So here are all the options that we have for basically turning a drive somewhere, a storage, into a DVC remote. So you can have a look at those and see if any of those can work for your use case. some errors are happening for some users. Yeah, sorry about that. I guess we can have a look at that. Maybe, I don't know if there are any specifics. Let me check. Some of you are not granted access. Yeah, that's right. So what Jervis mentioned, not everybody actually has access. It's only like the 21st people who are the fastest. Git username and email must be configured. Oh, yes. So this is actually something that you should do if you don't have a global setup for your username and email in Git. This is not specific to DVC. It's just something that you should set up in Git. You can just use git config, username and email. So I'll just, you can just do, maybe there's going to be a link. Yeah, there's actually a link on GitHub. So you can actually use this to do that. You would run into problems with many other things. So this is not specific to DVC. As I said, you can set up your own project if you want to, even in Studio. You will be able to do exactly the same thing, but it will just be for you. It won't be shared with others. Okay, so let me just jump back to code. Okay, so let me recap actually one more thing about the experiments. There's some more questions. So let me have a look. Yeah. What does DVC do if one of your stages imports another Python file? Does it calculate the hash for imports? Yes. It does. And if it's actually versioned, it's not going to be versioned by, it depends on how you version. You can version any file actually that you use in your outputs of the stages, either with DVC or with Git. If it's a script, if it's a Python file, then it makes sense to do it with Git. So if it's an output of a stage, you can add, I'd have to look up the syntax honestly, but it's like you specify that it shouldn't be cached by DVC, and it's going to be versioned by Git instead. And you can do that even with the larger data sets if you want to, but usually you won't want DVC to version those. Okay. The only thing that you really need to do is to specify the dependencies of each stage correctly. So if the stage depends on some other data, if your scripts load up something that's actually not captured in the dependencies, then it might look like, or if you have that randomness that I mentioned, then it might look like you have a reproducible pipeline, but it's not reproducible because not all dependencies are captured by the pipeline. But if you do that, then it should all be versioned. It should all the hashes should be captured, and all of that's going to be kind of collected in the DVC log here. Okay, right. So let me continue. Now we have our experiments, but we haven't actually made any commits or pushed any data or anything like that. So if I actually go back to Studio now, so we're actually getting more experiments still. But the commits here, as you can see, if I look at them here, they're called live experiments. And what those are essentially just they're capturing the metrics and potentially plots and potentially images from your experiments, but they are not pushed anywhere. Those are not commits that are pushed anywhere. It's kind of ephemeral here, and it's by design because not all experiments are going to be used. For example, there's this funny lich here which didn't produce anything. Maybe there was an error. When it was run. You probably do not need to keep track of that experiment. Or sometimes you just make a mistake, or sometimes you rerun the same thing twice. So you want to get rid of those usually. So the first thing that you can do, I don't want to delete anybody's experiments. Let me not do it, but you would just delete them here. And then if you want to persist them, however, you need to actually push them as commits. Now, DVC experiments are kind of, if you push them to the remote, they act, and even actually locally before we push anything, we have them here in our environment, but as commits, but they're commits which kind of lie outside of your Git history. And this is again by design. These are references which are separated from your Git tree, so that it doesn't kind of pollute it. If you look at our repository here, or as our experiment tracking, we have a lot of experiments. And if we just took all of this and added it to our Git tree, then that would pollute it a lot. It would be hard to see what was relevant, what wasn't. So we like to keep things on the side. This also means that if you just call git push, or if you call git push, these commits are not going to be pushed. There is a specific command called dbcx push, that I'm actually not going to use, which can persist these experiments and push them to the remote, but they're still going to stay outside of your Git tree. So you can version them if they're somehow important, but you can still keep them sort of separated. So this is our solution to keeping everything GitOps, so you can still version it with Git, but not polluting the Git history of your project. But right now, we actually want to move forward and take one of these experiments. And yeah, like I said, it's going to be mine. Sorry. And we're going to promote it and create a model out of this. So what I'm going to do is I'm going to take this rummy hard experiment, create a commit, and actually a commit to our Git history, and persist that. So let me do this. And the way I do it is by calling dbcx apply and the name of the commit. This rummy hard. In fact, I don't actually have to do it because it's the latest one that's been run, so it already is in my workspace. But just for demonstration, let me show it. All right, and this is going to take the stuff from this commit rummy hard, which I said is kind of like set aside from our Git history, and it's going to apply all of that to my workspace. So now my workspace contains the results of that experiment. It's actually exactly the same as it was, because this was the latest experiment, as I said. And now I want to push it, and I would actually want to create a model candidate out of this one that I'm going to version in the model registry and eventually deploy as a model. So let me just call git status here. Let me actually maybe git add everything first. So I'll just create a commit out of everything that's been created here. Now we can have a look at the status. And you can see that as far as Git is concerned, we updated only these things which are in code. So the git ignore files, which tell Git not to bother versioning the actual data. Then the dbc.yaml file, which is the pipeline, and all the instructions for the outputs of that pipeline, which are then going to be parsed by Studio to visualize it. The dbc log file, which tells me, okay, so this is the current state of my pipeline. And yeah, and then that versioned metadata file for our pool data as well. So let me just create a commit here and just call it first model candidate. And let me push that. And then let me also call dbc push to push the data sets themselves, the trained model, the trained model artifacts, and all the other things that we're versioning to our Git, to our dbc remote, which in our case is an S3 bucket. And it doesn't work. And I know why it doesn't work, because I didn't actually set up credentials. I forgot about that, and I forgot to tell you about that. So this is a good opportunity to do this. If we go to .dbc, we have this config file. This you would normally set up when you start your project, but it's already set up here. And here we're specifying that the remote storage for dbc is on S3, and it's a bucket called workshop remote. But obviously, what S3 is this on? We don't know, and we need to set it up somehow. For dbc to be able to communicate with this bucket, we need to set up credentials. Okay, so let me do that. And the way I do it here is I actually have this .env file with the credentials stored. There are multiple ways of doing this, but I'll do it this way. And then I have that make file that you asked me about at the beginning with this command S3 credentials, which just runs these two commands really. It adds the AWS secret access key and the access key ID to my DBC configuration. And this local basically makes Git ignore all that. So I don't actually pass my AWS credentials in plain text to my Git repo. So let me just call make S3 credentials. And now you're going to see them, but don't worry about that because this is a temporary account anyway. But let me clear it anyway. This is a temporary account, and even if you manage to copy it somehow, you won't be able to access it after the workshop. So now I set up actually my credentials here in the config.local file. And now I should actually be able to push things to S3 from DBC push. And it is doing that. And it's only pushing 2 files. And this is because I already ran this pipeline before when I was testing it today, which pushed all of the other things. The only thing that really changed was pushed. This is where this is actually a nice demonstration of how DBC is smart enough to recognize that stuff is already there and doesn't actually push and make redundant copies of things on the remote or indeed in the local cache. So now we have this experiment version. So that's great. And we can have a look at the model registry. So if I actually, again, go into our team, MLOps world, and we go to models, we see that we already have one model here from that test project that I was mentioning. And we have the same model as a matter of fact, but from our current repository added here as well. Now, how does Studio know that this is here? And the answer is exactly here, stored in the dbc.yaml file, where we have the artifacts section and the information about our pool segmentation model. And this in turn was created by that dbc live function here. There we go, log artifact. So now Studio knows that we have that model and we can work with it and in the context of our model registry. So, you can think about this as one step closer to production from experiment tracking. We have all of these experiments here, many experiments. Yeah, there are some issues. Yeah, there's also a question. So maybe we'll have a look at that in a moment. But let me go back to the model registry for now. And this is already something that's kind of describing a model that we hopefully want to push to production later on. But if I actually open this, it doesn't contain much, right? So there's a description of the model that we put in again in that DBC live function, some labels, all of the stuff that we filled in there. There's a path to the model file, which was also specified in the logging function. But that's about that. So this is not GitOps yet. It's actually not much anything yet. So what we want to do is we want to click here on the register first version. And it's going to ask us to pick a specific commit hash, right? And in fact, it's by default, it's going to offer the latest one that was pushed to the Git history. And in fact, it's also the only one in our repository in this case with a model. So it's just going to pick this one with the first model candidate. I'm going to go for that. We can specify a version name. I guess we can be more conservative and just call it version 001. We can add a message to it. And then we just click on register version. So great. So now it's going to take a few seconds. And it shows us that we now have in this pool segmentation model from this repository, we have a new version called, it uses semantic versioning. So it's this 001 version. And if I open the details of the model, actually, you can see that there's a lot more than before, right? So we have the metrics, we have parameters, we have plots, we have some images. So where did all that come from? So as you just saw, we specified a specific commit to denote as our model version. But that commit is also how we version experiments in our experiment tracking. So if we actually go to our project here, sorry, not models, to our project here, you can see that we have this commit called first model candidate, and we have all the metrics and all of this stuff saved here. So the only thing that we now do, or that the model registry now does, is it just picks up information from the experiment tracking. So for this model version, which is just another name for that commit, but one that we can easily keep track of, unlike the commit hash, we have all the information that we need. And of course, if we had more model versions, we could compare them between themselves. Instead of comparing them now, what we want to do is actually create some kind of a life cycle with our model, right? So let me actually, signify maybe that the model is in a development stage, and you do it by just assigning stage here, and you can choose any name for a stage. I will call it dev. And again, we just pick the model version, a certain message that we can add to it if we want to, or just use the default one and assign the stage. And again, it's going to be assigning a stage here in a few seconds. Now it's there. So it's in the version 001 is in the dev stage for this model. And now you might be thinking, okay, so that's great, but how is this GitOps? And before I answer, let me just add another stage, and then I'll just jump right into that. So let's say that now we've done something with the model. Maybe our colleagues looked at it. Maybe we tested it, stress tested the model in some kind of a test environment. We're skipping some of the steps like that here, and we just assign it to production right away. So I'm just going to assign the same model version to a prod stage. And it's going to do the same thing. And soon enough, we should be seeing that the model was assigned to prod. Yes, so we see it here. Okay, so that's great. But again, how is this GitOps? So one thing is that we connect here in Studio, we specified that the model version 001 is a specific commit. But that's still not GitOps. We want in Git to know that the same information is true. So from our Git repository, we want to see that this and that commit is version 001. And ideally, we would also want to see that, it was assigned to dev or to prod or anything like that. In fact, we would want to keep track of all of the model registry actions that we see here in the history. And we can actually do that. So as I mentioned at the beginning in the teaser, all of these things are manifested in the Git repository as Git tags. So these tags didn't exist before. A few moments ago, actually 5 minutes ago, there were no tags. And now we have these 3 tags here. So what do they mean? So the first one, you can see that they have a specific syntax. There's a model name. In this case, there's a model version, and then there's just a hash saying it's the first step. And it is connected to a specific commit, and that's exactly the commit that we chose in the model registry as our version 001. So now this tag is essentially capturing the fact that we registered this commit as our version 001. And the other tags do much the same thing. Again, they're attached to the same commit, and they're saying, okay, well, then as a second step, I assigned the model to dev. And as a third step, I assigned the model to production. There is a library called GTO, which is a short for Git Tag Ops, which is actually what's doing all of this under the hood. This is what Studio uses, and what you can also use if you work locally to create these tags and essentially manage the model registry with them. And this also means that if I just delete the project entirely from Studio and then decide to change my mind and re-import it again, then all of that is actually persistent here in my Git repository, and I can recreate the history from here again. So now this looks a little bit more like GitOps, right? So most of this is managed by commits, but these model registry actions are managed by Git tags. And yeah, you concentrate. The important thing is that you concentrate all of this inside your model registry. There's one last thing that I promised, and that's the continuous deployment, right? So actually, that's already been going on. Let us have a look at the actions here. So there are some workflows. If I open our repository, there are some GitHub workflows here. One of them is called DVC Studio. We're actually not going to use that one. That's for the automation, more CI level training. And then we have the deploy model workflow. And maybe let me actually open it on GitHub instead, right from the workflow that is running. And let me open the first one that was run first. So there's a workflow file. And what it does is it uses the fact that we so that the model registry actions are manifested as tags. So we can have a workflow which runs whenever we push a tag to our repository. And then we can have a job which actually uses, again, the git tag ops. We actually have a GitHub action for that, but you can also write this manually. And it parses those tags. If it's a GTO tag, in other words, if it is an action in the model registry, it will give us the event, for example, stage assignment of a model, the name of the model, the stage that it relates to, and the model version. The output will vary, obviously, based on the model registry action, but this is what we need to then pass to the deploy model job, which runs based on some conditions which we can create from the model registry actions. So for example, in this case, we're saying, okay, whenever I assign a model to a stage in model registry, go and deploy that model to a SageMaker endpoint. It doesn't have to be a SageMaker endpoint, by the way. That's just an example that we use here. You can run any deployment workflow that you want, but the mechanics are the same. So you always parse that model registry event based on what it was. You create another job that does something to it, and then you can, for example, deploy a model as we do here. The last thing I want to mention in this workflow is this dvc get, which is just a command that will let DVC download the model from our remote. So, remember that I pushed the model to the remote, which is this S3 bucket, really. Then in this workflow, I actually add that remote in the context of that runner on GitHub. And then I just call DVC get from inside of that workflow to obtain the model. And then there's a SageMaker specific script that actually deploys the model to a SageMaker endpoint. But if it's not SageMaker, you can change this part, but you can actually do exactly the same thing where you use DVC to get the right model. Again, since everything is versioned, you can be sure that it's the right version of the model, the right commit that created it. And then you can deploy it to a production endpoint or a testing endpoint or anything. So as you can see that the first run skipped the deployment. And why? Because of that condition that we have, right? So if we look at the workflow file again, we see that the deploy model only works on assignment. That is assignment of a model to a stage. But the first instance that this ran was when we created a model version and we didn't assign it to anything. So the deploy model job was just skipped, didn't do anything, but it did do something in the other two, and it's actually still running because then we deployed the model to dev and then also to prod. And we will actually have two SageMaker endpoint deployments here, each named after the stages and versions that this relates to. So let me just open this one. It seems to be, it's just finished. Great. So now we deployed our model. Let me just check the name of the model. It should be, I think, dev. Should be called something like dev version 001. Yes, this is the model name. Let me just copy that, because we now have an endpoint here on AWS. In fact, I don't even have to refresh it, it's here. So you can see that we have these two. There was one endpoint from before, which I already had here, just in case the deployment doesn't work for some reason. And then we have these two new endpoints that we just created, and we can directly run inference on them. Unfortunately, with SageMaker endpoints, these are not public. So once again, I will be the only one to query these endpoints because I'm the only one with the credentials. So, but let me just show that for demonstration. I have this endpoint prediction notebook here. Let me just fill in the endpoint name with the model that we just deployed. And yeah, the notebook is very simple. It just takes an image from our test data set, and then it uses the Boto 3 client to actually call the SageMaker endpoint. Then we just post-process the output so that it's easy to see for humans. So let me just run this. I think we'll just need to select the kernel and run this as well. It's going to take a while because this is a serverless deployment. So the instance, oh, that was quick. I didn't expect this to be that quick. So now we actually called that endpoint from the model that we deployed. And yeah, we have some results. I guess this can be improved. You can see the blue, the kind of, let's say, neon blue stuff is what the model thinks are pools. It's okay, but it could be better. But that's up to experimentation, of course. In terms of MLOps, in terms of deployment and managing all of this, we did quite a good job. So now it's up to the data scientists to iterate on the actual model performance. So yeah, we don't have that much time, so let me just recap, and then I'll try to answer the rest of the questions. So what did we just do? We started with some raw data that we imported with DVC, and we version here. So the raw data are in check. So for every commit, we have a 100% reproducible way to retrieve the raw data for training. So there is no worry that we'll train something on a different data set than we wanted in the first place. Or if we compare our models later, we can always go back to the exact same data set. Then we created a model training pipeline, which itself is reproducible and versioned and captured by this dvc.log file. So whenever we run it, it versions all of its outputs. And once again, we can make sure that if we go back to this commit and call dvc pool, provided that we pushed the outputs to dvc before, we can get exactly the same result. And if we actually rerun the pipeline, it will just say that everything is the same and it won't do anything. Then, so we have a way to create these reproducible experiments. We track those experiments now actually using Studio as in our projects here, and we can actually track the stuff that's still being run. But if we want to go GitOps, we eventually want to take some of these commits and push them to our remote, either as a part of our Git tree, or it's also possible to still push them, make them retrievable, but still keep them aside. That's not something that I showed, but you can do that too. So we took one of those experiments and or in this case, it was just me, but we pushed it to our Git history with a specific message to kind of denote it as something more significant. We then proceeded to create a model registry, which itself is 100% captured in our Git repo, or rather several repositories. This is where, again, Studio comes in because it can keep track of several repositories at once. But if we just have one, we can do that locally as well. And for our model, and we versioned our model, we assigned it to some stages, all of which is actually captured as Git tags in our repository again. Here I need to refresh because, yeah, as these Git tags. And since it's captured as these particular Git tags, this also gives us a way to create a CI/CD pipeline. Well, in this case, it's just a CD pipeline to deploy our models based on parsing those Git tags. So we ended up with a fully reproducible and fully GitOps machine learning pipeline. Okay, so let me just make one more comment that Jervis wanted me to mention, because if you are at the conference yourselves, there is going to be a brewery hop and tour tonight, where you can talk to the rest of our team, discuss what we maybe discussed today or some other things like the DBCX. So feel free to join. Let me also mention once again that on the 26th, there's the talk by Dmitry, our CEO, about DBCX. So if you're interested in LLMs, GenAI, and generally large unstructured data, this could be a very interesting talk for you. And yeah, that's basically it for me. So let me try to use this last 3 minutes to answer one of the questions. So at the end of my experiment, I get a following error. Is this expected or an issue on mine end? Failed to reproduce output is already tracked by SCM. Oh yeah, so I think what you did is you added things to Git as you were training things. You were adding things to Git that were then meant to be tracked by DBC. Maybe I would have to see the repository, but if you, for example, remove the git ignore and then you add the files that were created to Git, then it can create this conflict where it's not clear whether something should be actually versioned by Git or whether it should be versioned by DBC. But otherwise, I think you probably did correctly, but this is just something to look into. Maybe actually related to this, you can simplify your life by using pre-commit hooks, which DBC also offers, and there you can just use git pull, git push, all of that without thinking about DBC too much. If you set up those git hooks, there's those pre-commit hooks. There's stuff about that in the documentation, but you might not want them because sometimes they can be opinionated. I guess it depends really on your workflow. I can actually copy that here to the chat, so you can have a look at that. Right. So that's it. Are there any other questions? Screen share cut out. It's back. Okay. DBC model registry sync up with those tags. If you push tag in the correct format from your local machine, yes, you can do that. You could, if you use git tag ops locally, it can then connect back to the Studio, or alternatively, you could even just manually create the tags in the same format, but you probably don't want to because the GTO is a free open source software, so you can just use that. There's a link to the brewery hop. That's great. Still a bit unclear what's cracked by Git and DBC. Yeah. So you can just maybe go through the workflow again and try it out. But typically, you would version stuff with DBC that is not code and version everything else with Git. Okay, so thank you very much also. And I know you're going to different workshops now and talks, so enjoy the rest of the conference. Thank you. Bye-bye.